Okay, so we're gonna do velocity particle motion today. We just did this in class, like 1 or 2 chapters ago. So I'm gonna try to go through this quicker, and what I will be doing is this file here. I believe I gave it to you guys in class, but if you don't have it anymore, I'm going to just post this as a PDF file. But really, we should be memorizing this. Some of it you'll just have memorized as you go, and other things you might need to make flashcards to memorize. But just really, this is the key information that they can ask us. And it's not really a matter of if they're gonna ask this on the AP test, it's just a matter of when and where. And 9 times out of 10, it is a free response question. And so it's just, are they giving it to us as a calculator question or as a non-calculator question? And if it happens where it's not on the free response, then it'll be all over the multiple choice. So, just kind of first thing, we're going to go over just difference between distance and displacement, right? Total distance is our absolute value of the integral, and displacement is the integral with the just velocity without the absolute value. They will not give you the total distance on the non-calculator section with like an equation, but they might do it with a Riemann sum, so we'll go over that later on. When we see change direction, that's when the velocity changes direction. And I want to connect number 3, actually with, I want to connect number 3. Oh, is it not going to let me draw over this? Okay. So if we can do that, yeah. So let's connect number 3 with number 12, right? Those kind of go together. So when it changes direction, it changes signs. First, we need to set v of t equal to 0, which is when the particle's at rest. Then next, if they want us to figure out where is the particle, like where is the particle, what position is the particle at time 10 seconds, we're going to take the integral, but we need to make sure that we add on that initial position. So this formula here is very similar to what we did yesterday with the rate in, rate out, right? It's just that it's a part of the FTC, that fundamental theorem of calculus, which is all over the exam. Okay? For 5 and 6, I didn't give you the like opposites, right? Moving right means that the velocity is greater than 0. The opposite, moving left, would be the velocity is less than 0. Then slowing down, speeding up, let me see if it'll let me draw over this again. No. So slowing down, speeding up for number 6, we could even be thinking, there we go, I have to use a mouse on this one. We'd be thinking speed, oh, I know why. There we go. We'd be thinking speed increasing or speed decreasing, right? Slowing down would be speed decreasing. That is not, a lot of students get confused by this, and they just take the derivative of velocity and try to make that positive or that negative. The derivative of velocity is acceleration. And acceleration means that your velocity is increasing or your velocity is increasing, not your speed. So when we see this word either speed or slowing up, slowing down, speeding up, we need to check the signs for acceleration and velocity. What I have here is actually, some AP books will teach it this way, which is because we taught it as if they have opposite signs, right? We said if they have opposite signs, then it's slowing down, and if they have the same signs, it's speeding up. Well, if we think about it mathematically, if one is positive, one is negative, when we multiply them, that value will be less than 0. So that's kind of why that is. You guys can say hello to my daughter. She's not having a good morning. So 7, how far it has traveled, that happened once. How far it has traveled is the same thing as total distance. 8, maximum velocity. So we want to think, what are we trying to maximize, right? We're trying to maximize velocity. So we're taking the derivative of velocity and setting that equal to 0. And then we're going to just do it with like the number line analysis. If they gave us an interval, then we would do it with the table. Maximum speed, they're really not going to ask that. Unless they give you a graph. So maximum speed would be on a graph, whatever is furthest away from the axis. So in this case, our maximum speed would be down here. If that's further away, actually it looks like I went a little higher, so maybe up there. But whatever's furthest away from the axis because it's turning positive. Maximum acceleration, right? Same thing. We're going to take a prime and set that equal to 0. I have absolute maximum down here, and this could be, for absolute maximum, we could be thinking about the maximum position that it attains. So the maximum position, right? First we would set f prime to 0. In this case, f prime would be for position. So we would set, if we're using s prime equal to 0, or that would mean v is equal to 0, because s prime is the same as v. And then once we get our values, then we would plug them into a table, right, with t and s. And to get those values, those position values, we would need to use that formula there. Acceleration equals 0 should be obvious. These are kind of the two I want to talk about, are these average values. So when we see average acceleration or average velocity, and we basically have 2 choices, right? It really depends on what they're giving us. So right now, we want the average acceleration. So if they give you acceleration, then we're going to use this formula here, right? Because we have acceleration. Whereas if instead they give us velocity, we're going to use the average rate of change formula. The middle one, don't really worry about that, just connecting them. But it really just depends on which one they give us. Then for average velocity, same thing. If they give us velocity, then we're going to use average value because we have the same thing. And if instead they give us position, then velocity is the derivative of position, so we're going to do the average rate of change. Everything else on here is just really kind of review. Maximum height would be the same as what I did here. Now, one more that I want to add because it wasn't there. We just talked about average acceleration, average velocity. Well, what if instead they asked for average position? Okay, well, if we look up here, right, velocity is when we take the derivative of velocity, we get acceleration. So when we take the derivative of position, we get velocity. But there is nothing that we can take the derivative to get position. Position is like our starting point. So with position, we can actually only do this left one, this average value. So if they ever ask for average position, what we would be doing is 1 over b minus a, integral from a to b of s of t position dt. And they could use x as well. So really, that's all I want to go over with this. I just want to do some examples and kind of make that our notes. So I'm going to start off with this question from the 2016 free response. And with this one, I'll give you guys a minute, like 30 seconds to go ahead and read it. So this one was interesting in the fact that they immediately started off with asking speeding up or slowing down. Usually that's like a part C, but this one they just jumped right at it. So like we just saw, whenever we see speeding up, slowing down, that's where we're going to check our signs. So we need to check, they're using at time 4. So we need to check v of 4, which you're just going to type into your calculator, right? We have this equation. You'll just type it in your calculator, I don't have my calculator to pull up, but you could either do 1 plus 2 sine of t squared over 4 at time equals 4. Right, that's one way to write this. Another thing that you can do is you could graph this. I like to put them in the graphs just to make it easier. You graph this and then use trace and click 4. Or you can just type it in and change the t's to 4s. I like typing it in and doing the at 4 a little bit better because that way, remember on the AP exam, you guys are going to have been working for 3 hours by the time you get the free response. And your brain's going to be fried. So some of the mistakes you normally would never ever make in class, you make on the exam. So, typing in things wrong happens because it's such a long exam. And that can cost you a lot of points or a whole free response question. So if you type it in like this with the t's, when you enter, it basically formats it, and you can check and look, hey, does that look the exact same as what I was given? And just kind of check your work. So anyways, we type this in on our calculator, you guys should get something like 2.9787, and we're going to just write greater than 0, right? That's showing them that we're checking our signs. Then we want acceleration at 4. I'm going to write a of 4. It's good practice to write how it connects to what they gave us, right? They didn't give us an a of 4. So acceleration is equal to the derivative of 4. You don't have to write both, but it does really show the reader, the grader, that you know what you're doing. So that's negative 1.1640, and that's less than 0. And so then, because 1 is greater than 0, 1 is less than 0, we're going to say that that our particle is slowing down because v of 4 is greater than 0, a of 4 is less than 0. So velocity, you don't want to ever say it or they, right? So velocity and acceleration have opposite signs at time 4. Okay, we could probably get away with just this part, right? Like slowing down because velocity and acceleration have opposite signs, because you just showed it up here. I was just being a little extra careful. Hi, Emerson. Say hi to the class. Kara, I need you to come get her, please. I need you. Hi, y'all. So, anyways, number 2, B that we're going to look at, find all times t in the interval when the particle changes direction. So we see that word changes direction, right? That's not if it's on the positive side or the negative side, like direction means which way you're moving. So when we're thinking about moving, that's velocity. So it's where does the velocity change. So what we're going to want to do first is we're going to want to set v of t equal to 0 to get the times when the velocity is at rest. And then we can identify where it's positive, where it's negative. So when we do that, we get t equals 2.707. And again, in your calculator, because we have this 1 plus 2 sine of t squared over 2, and it has a sign especially, we really need to make sure we're looking at that interval. Because in your calculator, you don't have to write this by hand, you just wrote v of t equals 0. Monse asked yesterday, do I have to write v of t, or could I write 1 plus 2 sine of t squared over 4, or 2, equal to 0? That would have been okay also. You can write either one. But we're going to write solve, and then you're going to write that in 1 plus 2 sine t squared over 2, equal to 0, comma t. If we used f1 of x, then you'd write with x's. And then we're going to do the whole at 2 less than t less than 4. Right? So it's important to make sure we have that at part, because that's going to give us the 2.7 and not some other thing. Yeah, I think I wrote the denominator somewhere as 4. Or I said it. It's not. Is that what you're asking, Maria? Oh. Oh, okay. Yeah, I messed that up. You guys are right. Thank you, Maria, and Bruce, or whoever that, my volume's pretty low. Yeah, it says all times between 0 and 3. Thank you. So, I totally misread that. I guess that's what happens in the morning. So from 0 to 3. So this should have been a 0, and this should have been a 3. Okay, sorry guys, I had a little technical difficulty. So, yeah, so that solve was definitely between 0 and 3. Okay, so, once we do that, we get 2.707. All we've done so far is we've shown that that's where time equals 0. They said justify your answer, so we haven't justified it yet. So, to justify it, that's where we're going to make a number line. This is for v, right? We have 2.707, and we have from 0 to 3 as our endpoints. So when you're testing out values, you would need to test them between 0 and 2.7. You can either do that by just doing it on the graphing part, like typing in the 1 plus 2 sine t squared over 2 and then like at time 1. Or you can actually graph this on your graphing calculator and just see is it positive or negative. So when we do that, we will get positive and then negative. So the way we justify this is we say that the particle changes direction at t equals 2.707 because v of t changes from positive to negative at 2.707. So we need to actually explain our table, right? The table doesn't count for our justification. Alright, part C, find the position of the particle at time 0. So this is very, very similar to everything we did yesterday with that fundamental theorem of calculus. And that's that the position at any time, now they're asking for 0, is equal to the starting position plus the integral, so of v of t. Now, this one's a little bit different because usually we're given 0, but this time we were given time 4. So, because we were given time 4, we're going to have position at 4, and then that needs to be where we're starting, so it's from 4 to 0. So this integral kind of looks backwards. Normally we're going from 0 to 4, but we just need to make sure we're kind of confident with that setup, that s of 0 is what we're looking for. Sorry, what's that? Can you... Yeah, the position is 2 at time 4. So, like, the start, in this case, is time 4, not time 0. Does that make sense? So, I mean, you could have written it, like, if you really want to. We could have also written this as, let's see, s of 4 equals s of 0 plus the integral from 0 to 4 of v of t dt. But the issue here is what they gave us was s of 4 is 2, not s of 0. So, either way we do that, right, we're going to end up putting in, the 2 here or the 2 here. We'll get the same answer both ways, because if you look at our endpoints, see how they're flipped? But when we subtract it over, it's going to turn it negative. So the answer will work either way. I like this way, just because this is, I'm looking for s of 0, so that goes on top, right? We are given s of 4, so that's like our new starting point, right? Normally we're given like a starting point, but it doesn't really matter as long as this matches up with the bottom. That's the fundamental theorem of calculus. I guess another way to think of this is the 2 t values we're given are 0 and 4. Those are 2 t values. So if you wanted to, you could just literally do it as fundamental theorem of calculus. Integral from 0 to 4 of v of t dt equals s of 4, which is the top, minus s of 0, which is the bottom. And then this one here, we know is 2. And then we can solve for it. So really, any of those 3 ways would work. And when you take the integral, I'm going to kind of do this one. So I'm going to stick with that top one. So that top one was s of 0 equals 2 plus our integral from 4 to 0. And when we do that in our calculator, we'll get s of 0 equals 2 plus, and then you get a negative, you get negative 5.815. And so that gives us that s of 0 is negative 3.815. And it's okay that it's negative. That just means that we were starting to the left side at time 0. Okay, part C says, or that was part C, huh? Part D says, find our total distance of our particle. And this one on the calculator section, if they give you this, like, that's the easiest thing ever, as long as you can remember the formula for distance, but you don't have to do any work at all. So our distance is just the integral from 0 to 3 of the absolute value of v of t dt. So really the only thing on this one is just that you know how to type this in. If you guys have your calculators, I would highly, highly, highly recommend just practicing typing that in. If anyone left their calculators at school, maybe send me an email and we can see if we can get, like when there's a time for you guys to pick them up. But this absolute value symbol is just, it's in the same menu as the integral is, as the derivative is. So you're just going to type that in, and you get 5.301. And on this exam, that was worth 2 points. So literally just remembering the formula, typing it in, gave you 2 points, which is awesome. The nice thing about particle motion is you guys can pick up a lot of points if you kind of learn the patterns of these. So next one, this was actually not on an AP exam. This is just an AP style question. So we have Steven is skateboarding along a straight road. His velocity in meters per second, right? The one before with the particle didn't give us units. This one does, so the units are going to be worth some points. His velocity in meters per second is continuous and differentiable. Whenever we see that pop up, either sometimes they just say differentiable, and if it's differentiable, you know it's continuous. But whenever we see this pop up, it's a really good indicator that you're probably going to have to either do MVT or IVT, or both. So we'll get there in part C and D. We're going to start off, so A says approximate Steven's acceleration at time 4. I did not put this in that table, but it's probably good to add. I'll try to add this before I actually post the PDF. If we wanted to get acceleration from like a table, right, of v of t, it's actually the same as the average acceleration, right? Our approximating is going to be that same average, that v of b minus v of a over b minus a. So in this case, we want to approximate at time 4. We don't have time 4, but time 4 would be somewhere in between 3 and 7. So that's what we're going to be using. So we're going to just say that a of 4 would be approximately v of 7 minus v of 3 over 7 minus 3. And that gives us 0 minus 3 over 4. So that gives us that a of 4 is approximately negative 3/4. And now it's said to indicate units of measure. So anytime it says that, it's probably worth a point, or you don't even get this point without your units. So we had velocity was meters per second, and we just need to remember that anytime that we do an integral, we chop off a per time. And anytime we take a derivative, we add on a per time. So in this case, y2 minus y1 over x2 minus x1 is similar to a derivative, right? Riemann sums are similar to an integral. So in this case, we essentially did a derivative, so our units are going to be meters per second squared, or you could write meters per second if you want. Alright, B says use a trapezoidal sum with 4 subintervals. A lot of times you can basically expect that on the AP test somewhere you're going to have to explain or interpret a derivative, and somewhere you have to explain or interpret an integral. So we want to remember that integrals are always just a change in something, and the one exception is this one here when we have the absolute value, that's the total distance. But otherwise they're always the change from 1 to 10. Now, when we're doing this trapezoidal sum with absolute value, it's really no different than doing it normally, except that our negative numbers are just going to turn positive. So otherwise we're just doing our same trapezoidal sum that we always do. So what we're going to write is we're going to say that the integral from 1 to 10 of the absolute value of v of t dt is approximately, and then so between 1 and 3 that has a change of 2, so it's 2 times, and now we add up negative 2 and 3, but because of that absolute value, that negative 2 turns positive 2 plus 3 over 2. And plus, now from 3 to 7 that has a width of 4, so plus 4 times, and then we're going to have 3 plus 0 over 2. And I'm going to just add on down here. Plus from 7 to 8, that has a width of 1. Right? And then we're going to have from 0 plus, now the negative 4 is going to turn positive over 2. And plus the last width is 2. And that negative 4 again is going to turn positive. 4 plus 7 over 2. And so you would add all of those up. The 2's here cancel. The 2's there cancel, and the 2's here cancel. So that gives us 5 plus 2 times 3 is 6. Plus 4 divided by 2 is 2 times 1 is 2. And plus 4 plus 7 is 11. And honestly, you can actually read your answer like that, but it's calculator section, there's really no need to. So that gives us 24. And then remember that we took an integral, so we're going to chop off units. We had meters per second, so we're going to chop off the per second and it's meters. Now, that gave us probably 2 points there, one for the 24 and one for the work. The third point is going to be this using correct units, interpret the value. So what we're going to say is that the integral from 1 to 10 of v of t dt. Now, they're not asking us to interpret the integral, they're actually saying interpret this value. So I'm going to just say, I'm going to use 24 as well. So I'm going to say represents the, now we said the integral of velocity is position, but when we add absolute value, it's the total distance. So it's the total distance. And a lot of times we would say in meters, but because we have an answer, I'm going to just say the total distance of 24 meters. And we can add, right, this guy's name was Stephen, that Stephen traveled. And then we always need the where, or the when. So that Stephen traveled, and it was between 1 and 10. So that Stephen traveled from 1 to 10 seconds. So our keys there are that we get in the word total distance, that we have our units of meters, and that we have our location of time. Right? C and D, this is where we're going to get to that IVT, MVT stuff. So explain why there must be a time t for 1 is less than t, less than 10. Immediately you're going to jump to IVT and MVT. IVT is that essentially when we have IVT, what we're analyzing is we're analyzing, say, we want, like we want to know if v is equal to 0, and so we want a v that's negative and a v that's positive. That's going to be IVT. MVT is going to be that, MVT is that we want a v that's equal to 0, but we're looking at the positions. So we have position, so the derivative of position, right, would be velocity. So that's like s of b minus s at a over b minus a, because we were given a position and we want to look at velocity. So with C, they want to know, explain why there's an acceleration that is 1. So immediately I'm thinking more along the lines of MVT to start, because we want to know that there's an acceleration at 1. Now this one's actually really tricky, because we saw a couple of these where it was like acceleration 0, and then we were looking for the same number, right? We were looking for like, say, a 3 and a 3. Well, this one doesn't want 0, it wants 1. This one actually we have to use both MVT and IVT, because if I kind of look up here, this acceleration at 4 was like a negative 3/4, but it wasn't 1. And nowhere in here, if you do y2 minus y1 over x2 minus x1, will you get 1. But what we can kind of think about is this value velocity is negative, and it's increasing to 3. So what that means is between negative 2 and 3, I had to have a positive acceleration because I was increasing. Now, from 3 to 0, I decrease. Again, even from 3 to negative 4, I decrease. And then from negative 4 to 7, I increase. So if it asks me how many times it changes, we'd go there. But I like to increasing and decreasing just because 1 is close to 0. And we can kind of use that as a starting point. Really what I'm looking for is there an acceleration bigger than 1 and is there an acceleration smaller than 1? So because we have acceleration, right, we're looking for acceleration, not velocity. We need to be thinking about that acceleration is the derivative of velocity. So like between 1 and 3, right, are basically what we could say is that there must be a prime of some time t. So there must be a time t where the acceleration is equal to v of 3 minus v of 1 over 3 minus 1. This is what MVT says, right? This is MVT. So now what would say is we need some acceleration at time t where, so v of 3 is 3 minus negative 2, that gives me 5. So it needs an acceleration of 5 over 2. So this is like by MVT, between 1 and 3, there's an acceleration of positive 5 halves. That's 2.5, that's bigger than 1. Now we can do this again for one of those decreasing sections. So from 3 to 7, right, by MVT, there must be an acceleration that is from v of 7 minus v of 3 over 7 minus 3. And we already solved this back in part A, and we got negative 3/4. So now, kind of just thinking, right, this is a positive acceleration, this is a negative acceleration. So in between those 2 points, it would have had to cross 0. We don't want to cross 0, we actually want to cross 1. So what we would kind of say is that using this, right, there must be an a of t equal to 5 halves over the interval 1 is less than t is less than 3, and a of t equal to negative 3/4 over 3 is less than 7 is less than t by MVT. Now, that just showed that there's an acceleration of 2.5 between 1 and 3, and negative 3/4, negative 0.75 between 3 and 7. We didn't yet say why it has to be 1. So now we want to say, add on to that by IVT, then there must be an A of t equal to 1, because, right, those values are in between, right? So because 5 halves is greater than 1, which is greater than negative 3/4. So we're saying that in between 5 halves and negative 3/4, it has to pass through 1. This was pretty tricky because it had both MVT and IVT, but it kind of, I like it because it goes through that. So D, what is the fewest number of times that Stephen can change direction? So when he changes direction, what's happening is that his velocity is changing from positive to negative. So we actually don't care about the zeros, we care about positives and negatives. So here we have a negative velocity and now a positive velocity. So by IVT, what had to happen here? We had to get a velocity of 0. Now we have a positive, and then we have a negative. So again, by IVT, between these two, we had to pass through 0. And from negative 4 to 7, we had to pass through 0. So the fewest number of times he changes direction, that's 1, 2, 3 times. And so we would say 3 times, right? And we can just explain each of them, right? From 1 less than t less than 3, velocity changes from negative to positive. And maybe we could add in like by IVT. And then I'm not going to write all of them. You would just do the same, what I did here. From 1 to 3, you'll do that, and then you'll repeat it again for between 3 and 8, and you'll repeat it again between 8 and 10. You just rewrite it, right? So last one we're going to look at, and this one I'll go through faster because it's very similar. So this was, I believe, the 2018 exam. And so this one is more traditional. They give us x equals negative 5 at time 0, right? They're not doing that weird at time 4. And they give us an interval from 0 to 3.5. So A says find the acceleration. This is really where, and again, I didn't go over this at the beginning because it was so recent, but we really need to just make sure we're good with that ladder, right? Position, velocity, acceleration. We go down the ladder, we're taking the derivative, and we go up the ladder, we're taking the integral. So in this case, we're going from velocity down to acceleration, we're taking the derivative. All you need to write on the exam is, let's see, oh, I skipped way down. So all you need to write on the exam here is A of 3 equals and a number. Now, if you want to, it's good practice, like I said earlier, we don't have an equation for A of 3, we have V. So it's good practice just to connect that to what we're given. So A of 3 is the V prime at 3. And then you can actually type this into your calculator in one line. So what you can type in is d dt of, right, it's going to give us a box, 10 sine, all that stuff, at time equals 3. Just make sure that this at goes outside of the parentheses, like outside of that little box. Right, if it goes inside, what you're going to get is you're going to get an answer of 0, because they're going to plug in 3 first, and the derivative of any constant is 0. So you need that 3 outside. If you're worried about that, then just do it in separate lines. Anyways, I'm not going to really go through the answers, I just want to go through on this one, how we would do everything. So B, find the position of the particle at time t equals 3. So to find the position of the particle, we've done that already today. We want the position at time 3. So we're going to say that the position at 3 equals the position at 0, because that's what they gave us, plus the integral from 0 to 3, right? The 0 goes on bottom, the 3 goes on top, of v of t dt. And for the s of 0, you're going to get -5, plus, and then for the integral, we would just type it into our calculator, we'll get a number. Alright? For c, c wants us to evaluate both v of t and absolute value of v of t. So, both of them, you would just type into your calculator. It's like a free point, maybe a free 2 points. Right? You just type this into your calculator, then you type it with an absolute value into your calculator. Now to interpret the meaning of each integral, and this didn't give us units, so we don't even need to use units. We just need to remember that this first one is the change in position. And we need to make sure they didn't give us units, so we don't need to report them, but we do need to report from t equals 0. Oops. From t equals 0 to t equals 3.5. And then for our absolute value equation, that's our total distance the particle travels. And again, we need that same from t equals 0 to t equals 3.5. Alright, and then the last one, a second particle moves along the x-axis. And when are they moving at the same velocity? So this one, the only difficult part on this one is that the first particle we had a velocity for. And the second particle we had a position for. And they want to know when do they have the same velocity. So my kids took this 2 years ago, and a lot of them, when they got back, said that they messed that up because they just set the two equations equal to each other. But the key here is realizing, hey, wait, this is the position. So what we know is that, right, the first particle has a velocity of 10 sine 0.4 t squared over t squared minus t plus 3. But our second particle, instead, has a velocity of 2t minus 1 because we have to take the derivative. So now that we have that, now we can set these two guys equal to each other. So on your calculator, you just use the solve button, right, solve, and then set this equal to 2t minus 1, comma t, and then at 0 less than or equal to t, less than or equal to 3.5. So there's that. Before you guys leave, I know that there are about 15 of us here. I know there's a lot online right now about how our AP exam is going to look. The one thing that I've been reading with everything is that as of right now, they're really not moving the AP exam. They might have schools apply for extensions if they got totally shut down and weren't able to do any online stuff. We're not going to qualify that because we are doing online stuff. So as of right now, they're saying the AP exam is on the day it is. I read everything from them saying they're going to look into take-home testing versus they're just going to proceed with the test. My guess is that, you know, say worst case scenario that school closures get extended past spring break. My guess is they would still do the AP exams and just have everyone like 6 feet apart or something like that in NPR because the take-home test is just too difficult. They need to make sure every kid has a Chromebook, and then it gets into privacy stuff because they have to use your webcam to make sure you're not cheating, and it's like an AI program that they use. So my guess is they probably won't go that route, but regardless of how they administer the test, the big constant I've seen is that they're trying to keep the same date. So that's what we're going to plan on. Now, I'm going to post the homework right now. Let's see, I got it over here. So our homework is 3 questions. It's 9:30 right now. I need to actually be somewhere closer to like 10 today. So what I will do is that I can probably extend a little bit if we go like 10 minutes this one and then go over it for 5-10 minutes. 10 minutes to work on this one, go over it for 5 to 10 minutes. 10 minutes on this one, go over it 5 to 10 minutes. You would be done. If you'd rather do it on your own, then you can log off and do it on your own. I'll post it right now. Sound good? And thanks again, guys, for showing up. I know it's early in the morning, but thank you for logging in. Actually, I wasn't recording, so I'm going to start that over. So I think this one was a little bit easier. So anyways, this one was one of the first years where they changed or right before they started changing the format of the calculator questions. So this one almost, A and B almost could have been non-calc. So, right, like with A, if we take the derivative of ln of t squared minus 3t plus 3, you guys should be able to do that derivative by hand. And so, right, we had ln of t squared minus 3t plus 3 as our velocity. So when we try to do like a prime of 4, first we would just do, or a of 4, first we do a of t, which would be the derivative, so 1 over t squared minus 3t plus 3 times 2t minus 3 for that chain rule. And so we can just put the 2t minus 3 on top. Right, and I'm going over this because I wouldn't be surprised if on the AP exam they ask you to do something like this. You're absolutely going to have to do something like this at least somewhere. So an a of 4 would just equal 2 times 4 is 8, 8 minus 3 is 5, over 4 squared is 16, minus 3 times 4 is 12, plus 3, and that gives us 5/7. So even though this was a calculator question, parts A and B, you could definitely practice doing non-calc as well. So 5/7, if you used it on your calculator, you might have got it as a decimal, 0.7143. I wouldn't do this by hand, like on the test. If you have a calculator, use it. But just as we're reviewing, it's nice to go over. So same thing here. For me, this parentheses, I would never do because I have a calculator. But if they did ask us non-calc, which they could, right, when we set an ln equal to 0, to get rid of the ln, you have to go e to both sides so they cancel, and e to the 0th power is 1. We move the 1 over and then we can factor it. Now, we had a calculator, so we would just on our calculator use the solve button, we get 1 and 2. They want to know where this changes direction, so we need to make sure it does change direction, so we're going to do a number line. Right, at 1, velocity was positive between 0 and 1. Between 1 and 2, it's negative. Between 2 and 5, it's positive. So it's changing in both 1 and 2. Make sure you explain that. Right, it changes direction at time 1 because velocity changed from positive to negative at 1. And at time 2 because velocity changes from negative to positive at 2. And then it wants to know where is this traveling to the left. So it's traveling to the left between 1 and 2 because, oh my gosh. Let's see. That's weird. There we go. So it's traveling to the left between 1 and 2 because that's where VFT was less than 0. Okay. Alright, part C, find the position. This is really, really standard. We've done this a bunch today. I don't think I need to go over it too much. Right, just s of 0 plus that integral. And then part D was a little bit different, right? Find the average speed. Now, usually, right, it's average velocity or average acceleration, but we just kind of need to remember that speed is the absolute value of velocity. So, if we think of this question as what if they had just asked us for average velocity, right? And we kind of come back here, and average velocity is either if we have velocity, then we do our average value formula, if they give us velocity. And if instead they give us a position, then we do our S of B minus S of A, our average rate of change. Now, they gave us, in the question, actually I got it over here, they gave us a formula for velocity. So if we were doing average velocity and we're given velocity, then we're going with the average value formula. The issue is, instead of velocity, they want average speed. Well, we know speed is just that absolute value, so that's all we're going to do is just the average value 1 over 2 minus 0, integral from 0 to 2, but then of the absolute value of VFT dt. We got one more question, let's kind of speed through it. Okay, same thing, I thought A, B, and C pretty easy. D, a lot of times this gets a little tricky. But the nice thing about these particle motions are you can really rack up a lot of points because they're all so similar. A asks us to find acceleration. We just take the derivative, plug it in. And it asks, is the speed increasing at time 2? Why or why not? I think I actually answered this a little bit wrong. We probably should have the word no in there because it says, is the speed increasing? So we should probably say no, the speed is decreasing. But we're just speeding up, slowing down, we're checking signs. We're plugging it into velocity, which was negative 2.72. Then we're plugging into acceleration, which we already did, which was positive. For B asks to find all the times the particle changes directions. We've done this a lot today. So changing directions, we're going to set VFT equal to 0, find when it's at rest, and we get 2.506. On your calculator, because you have that sign, make sure that we use the interval. And then we're going to make our table. I actually made a big mistake here, and that I did not label my table, or my, not table, my number line. We always need to make sure we label these number lines or we won't get points for the justification. So this needs to have a little V next to it. I would have actually probably lost this point here because I didn't have that V. So, then we explain that the particle changes direction at time 2.506 because velocity changes from negative to positive. C, they gave us 3 points for C, which I think is crazy. Which is, I mean, in a good way for you guys if you're taking the exam. So, you get total distance is just the integral of the absolute value of velocity, which is something you memorize. They give you guys, yeah.
You don't need to add the 1 that they give you, like the initial?
Okay, yeah, you do not add the 1. You would have gotten 2 out of 3 if you added the 1. That's a really good question. So, position, the initial matters, right? Distance is just how much you physically walked, right? So, like, say you were walking to the school, and instead of starting at your house, you, like, start, say, like, you want to track it on your phone. But you actually don't track it until you're 5 steps, like, in front of your house. Your phone's not going to care if you start moving towards your house, but then you, like, go backwards because you forgot something. It's going to be tracking your distance, right? But did it track it from your house or from the beginning at 5? Right, it started at 5 already, but it's treating that, like, starting point as 0. Does that kind of make sense?
Yes.
So it might help if I draw it out. So let's say that, right, this is your house, and here's the school. We'll draw them as the red gates. And you started your, like, distance tracking app here. So you already started, you were already 5 feet away. Okay, it doesn't care because when you start your, like, on your phone, if you open up, like, Google Maps or whatever, like, your health app you have, it doesn't really know that you're 5 feet from your house. The phone doesn't care about that. It's just saying, hey, we're starting right here, and now how far are you going to go? Maybe I start coming over here, and I walk, like, you know, say 1,000 feet. But then I realize, oh crap, I forgot, you know, my graphing calculator, I need that because calculus is the most important thing ever. So I go back 1,005 to get to my house, and maybe then after there I go back to the school, and that was another 2,000. So it's just going to add up those 3 of what I walked since I started the app. It doesn't include where I was when I started it. Right? So total distance is just what we changed. It doesn't include any starting points. Whereas with position is totally different. If I was doing position on here, right, on position, I would care about the starting 5, and I would then only care about basically the difference between my house and the school, because that's where I ended up. Does that kind of make more sense that way? So the key is just kind of to remember and to realize that if they're asking us for position, then our formula is that like S of t is equal to S of 0, or it might not be 0, it might be another number, but from 0 to t of the velocity. Right? And because it's position, which is the like distance from our starting point, then we care about that initial. But if they're asking us for distance, we don't care about the initial. We only care about how much did we travel, or how many steps we took. Right? How many steps we took between 0 and time. It doesn't matter if we started at 0, at 2, at 6, at 10. It's just the like steps that we take. And so, just kind of memorizing these formulas, right? The distance formula is always this. So our distance formula is always just going to be that without any initial. Whereas the position formula, purple and green don't mix, but is here in green, right? The position formula does include that initial. All right, good question, for sure. Now, D, I thought they were just jerks on D, because they use the word distance, but they're saying the distance between the particle and the origin. So, really, the distance from the particle and the origin is, in other words, it's just displacement, okay? Right, because if I wanted to say I'm here at the origin, right, and I want to know the distance of the particle, maybe the particle's here, I want to know that distance, that's just the position, the displacement. Now if the particle's over here, that again is just the position. So, part D, I don't like that they asked this. They haven't asked it, again, this was in 2003. They haven't worded it this way since then. So I don't think we would have it worded this way. But it's just the position. So to get those two numbers, I should have written this down. To get those numbers, right, what I did was I said, okay, well, the maximum position is going to have to occur at either an endpoint or a critical point. And we already did solve v of t equal to 0. So, there we go. We already solved v of t equal to 0 up in B, and we got 2.506. So it's going to happen at 0, 2.506, or 3. 0 was a given. They gave us 1. For 2.506 and 3, that's where we do include that initial. So, because now we're not, even though it says the word distance, because it says distance between particle and origin, that's actually more the definition of position. So we want to know what is the position at that 2.5, was it 06? Yeah, 2.506 number. Now we're going to say the starting point 1 plus the integral from 0 to 2.506 of v of t dt. And when we do that, we get the answer of negative 2.6, or 2655. Right now, that's our position. But the way they worded it was, what's the distance between the particle and the origin? Well, if the particle is located at negative 2.2655, then between the particle and the origin, the distance would be a positive number. It would just be positive 2.2655, right? Because distance can't be negative. And then we would do the same thing with 3. So we just do this over again, but we just change this guy to a 3. We change this guy to a 3. And we get a new answer. We get negative 1.9715. Now, on the grading sheet, I was looking at the grading sheet, and it said whether you reported it as positive or negative. Here, they gave you the point. So, even though they worded it confusing, I think they realized that, and so they were generous with giving you the point, even if you had reported it as negative. So then,
Could you
yeah.
your explanation? Why is it at t equals 3?
I don't know. Yeah. Thank you both of you guys, Michael and Brisa. This is absolutely not 3. This is, I don't have a way of writing over this. But yeah, it's at 2.506. I was just working fast. So, that's another reason to make sure you're checking your work, right? Like, right now, even if it's just morning, we haven't taken a 2-hour exam. I'm making mistakes. You always just want to go back and check it. If you have any extra leftover time, and just the big thing is just checking like those silly mistakes, right? So that answer should have been 2.506. That's the when it's further away. Good catch, guys. So again, thanks for coming. Do we feel okay with these? Do we think that this format's working good? Yeah. Okay. So that's it for today. If you guys stayed this whole time, then just should be easy for you to turn in your homework, and I'll see you guys tomorrow.